Alright guys, today we'll be doing another great circle sailing problem. I've done a couple of them before, but the reason I'm doing another one here is because this is one of the longest and the most complicated questions that students face in celestial or coastal navigation. Alright, so I'm just taking another example here. It's a bit of a long of a question, it's quite lengthy, so we'll go slowly. But I'll try also to keep the video as short as possible so that you guys don't get bored. Alright, so I'll straight away go into the example. You have to solve this great circle sailing question, and this includes intermediate points as well. Alright, so the example here asks you to calculate a few different things between two given positions. So the two positions are given to you, a departure position and an arrival position, and between these two positions you have to find the great circle distance, initial course, then final course, and based on the initial and final course you will determine the position of the vertex, and then using Napier's rules you calculate the position of the vertex and find out the position of the intermediate points, the longitude for intermediate point of a latitude and a latitude for an intermediate point of a longitude. So 6 different things to find. So let's start up. Alright, so now you've got these two positions. The first thing that you do is plot these two positions. Now while one of them is in the southern hemisphere, the other one is in the northern hemisphere. So position A is 33 degrees 51 minutes south, 151 degrees 16 minutes east, and position B is 37:47 north and 122 degrees 30 minutes west. Now the A is in southern hemisphere and B is in northern hemisphere. So when you're drawing the pole, you always determine the pole by the value of the higher latitude. Alright, so in this case the north latitude of position B is higher latitude, so you will draw the north pole. In my previous example that I solved the great circle question, the southern latitude was higher, so I drew the pole towards the southern latitude. Alright, but in this case the northern latitude is higher, so you draw the northern pole. The second thing you guys have to notice that the longitudes are very close to the anti-meridian. Alright, so normally how do we view longitudes? We view longitudes like this here. Alright, so we've got 0, 0, 0 degrees here, which is the Greenwich meridian, and the east longitudes appear on the right side. These are the east longitudes, and the west longitudes appear on our left side of the 0, 0, 0. Right, but what happens here is this is the anti-meridian. So if you just visualize the east longitudes going all the way around the surface of the earth onto the other side of the earth, or rather onto the other side of the Greenwich meridian, which is your anti-meridian or 180 degrees meridian, then the opposite thing happens. So your west longitude comes, so if I make this 180 degrees, so what happens is on the other side it reverses, so this becomes, so on your left side you have your east longitude, and on your right side you get your west longitude. Alright, so I've explained this in my other videos as well, so hopefully you've seen them. If you not, just go and find the other videos and you will realize what I'm talking about. So I came all the way from the surface of the earth like this, and now over here, and that's why, and the west longitude as well. So I'm coming all the way from the Greenwich meridian, and now I come here. So my east and west longitudes are very close to the anti-meridian. So 151 degrees 16 minutes east comes here, and 122 degrees 30 minutes west comes here, very close to the anti-meridian, and this is the D long. And since I'm going from east to west, you might think I'm going in a westerly fashion, but you will see that I'm going actually in an easterly fashion. Right, so I have explained all these concepts before, but I'm just repeating it for the sake of those who may be watching this video first and you've not watched my other videos. Alright, so let's plot the position. So I've got the position here, I've drawn the north pole, and I've got position A and B. A and B are plotted. Now you have to find out PB, side PB. So this is a spherical triangle, so PAB form a spherical triangle, and if I have two sides and the included angle between it, I should be able to solve the question. Alright, so I've got PB, which is so if B, this is the equator, so you can see this is the equator, 0 degrees, so the distance from B to the equator is 37:47, so PB becomes 90 minus 37:47, which is the latitude of B, and you get 52 degrees 13 minutes. Alright, similarly from equator to A is 33:51 minutes south, so PA you will add 90 degrees to this to find out PA, and that's what I have done, plus latitude of A. So when you do that, you get 123 degrees 51 minutes. Alright, so these are things that you have to note down. and make sure you don't make these mistakes, because sometimes if both positions are in the northern hemisphere, then you will subtract from 90 and you get the sides. If both of them in the southern, then you subtract both sides from 90 and you get the sides. But in this case, one is in the other hemisphere, so for one you will have to add 90 and for the other you subtract from 90. Alright, and then again I have drawn the concept of the antimeridian and the longitude, so I will not go through all that again, and I will try to erase all this so that you guys don't get confused by what all I have written here. So if you didn't understand, just rewind this video and watch it again. Alright, because if it's too much of coloring and text, you might get a bit confused. Alright, so with that I'll keep going. I have explained this concept already here, so you know the d long between A and B, so you are in an easterly fashion, and the interval between these two positions or the difference between these two positions in terms of longitude. So the rule normally is when two longitudes are in different size, east and west, you add them. So if you add them, you get 273 degrees 46 minutes. And theoretically, if you are going from east to west, you will say you are going in westerly fashion. But because this is greater than 180 and d long can never be more than 180 degrees, you subtract it from 360 degrees and then reverse the sign here. So automatically this becomes easterly direction, which is also the case where we have drawn the diagram, and you can see that conceptually also your vessel is actually going from east in an easterly fashion, alright, from A to B. And similarly your d long, which is also angle P, becomes 86 degree 14 minutes. So when you go back to the diagram here, you get your two sides and you get your included angle, which is required for cosine rule. And if you don't know what cosine rule is, I have got one video regarding cosine rule. Alright, so watch that video and you will be able to understand what is cosine rule and why do we need to find these two sides and the included angle to solve the cosine rule. So alright, so once you have all these three values, you straight away come and apply the cosine rule here. Put the included angle cos P equals cos AB minus cos PA cos PB divided by sin PA sin PB. Alright, what you have to do is basically find AB, which is the great circle distance. So you can see then it's just a matter of putting in the values and then transferring the values based on what is known to you, what is unknown to you. So because AB is unknown to us, we basically take the knowns here. So this goes on to the other side, becomes a multiplication sign, and this also goes on the other side and becomes an addition sign. And this is what I have done here. You can see that, right? So simple transposition, which is the basic of maths. You do that, follow my prompts, see the values that I have put up, solve one by one. So solve this value here, cos 86 14, sin 52 13 and sin 123 51 first, and then solve cos 52 13 and cos 123 51. Retain the negative signs like I have and keep following the prompts here. In your calculators, this is what you should be getting, right? Once you get cos AB equals minus 0.29815, you transpose the cos on the other side, it becomes a cos inverse, and AB you will get as 107.35 degrees. But AB is a distance, so to get my great circle distance, I will multiply 1 degree equals 60 minutes, which is 60 miles in nautical navigation, and then 107.35 degrees multiplied by 60 gives you 6440.8 nautical miles. This is my great circle distance, but for the rest of the question I will still use 107.35 because I would need degrees. Alright, but for the answer, this is your first answer. I'm just going a little bit fast because this is a very long question. I don't want this video to be very long as well. Alright, so then we have to find our initial course. So this is our second thing that I find, and A is your initial course and this is your internal angle A. So what do I mean by internal angle is, if I go back to the diagram here, what I'm trying to find out is my initial course. So this is the angle, the internal angle I'm trying to find, because my vessel is going like this, right? And this is being measured, this angle, internal angle A, is being measured from the pole. You always measure the course from the pole, alright? But what will happen with B is, I will have to measure how the vessel is going like this. So I will have to measure the outer angle. So first I will have to measure the inner angle B, and then I will have to subtract it from 180 to get my outer angle. But let's start with A first. So I am getting my internal angle A, and again I use the cosine rule because I have got the angle and I have got the sides next to it. So I have got A and I have got the sides which are next to it, which is PA and AB, right? So using the cosine rule, I have simply put in the values here. You can see how the values work. Alright, make sure that your answers should match with mine, that one I have put up here. Stick to 4 to 5 decimal places, that gives you reasonable accuracy. 2 decimal places is too less, but 5 decimal places is pretty good actually, and that's what we normally use in these kind of questions in great circle. Alright, so keep following these answers and make sure your answers match mine. Return the negative signs if you see any. But as soon as you get cos A equals 0.56334, take cos to the other side, becomes the cos inverse, and what you should be getting is A equals 55.7 degrees. Because it's a cos, I don't want to have it in decimals. To get the cos, I will round it off to the next figure because it's more than 0.5, so this becomes 56 degrees. And how do I get my northeast? Alright, so I'll go back to my diagram. So I've written initial cos is northeast, so you can see this is in a northeasterly fashion, right? So if this value was more than 90, it would be in the second quadrant, which is southeast quadrant. So if you know the quadrants, right? So this is north, this is east, south and west. Now if the value was less than 90, it would be in the northeast quadrant, which is in this case here. If it was more than 90, it would go into the southeast quadrant, right? But in this case it is not, because the vessel is going in this direction. It has to be northeast or southeast. It's going in this direction here, right? So it has to be northeast, cannot be northwest. You can see that it's going in northeast, but sometimes it can be in a southeast because it's a curve, so it may start off as a northeast and then go into a southeast course. But in this case, where the value of internal angle is less than 90, so it's still in the first quadrant, the northeast quadrant. So that's why I've put northeast in the initial course. Alright, over here. So that's why my true course is 056 degrees true. Alright, so I've rounded it off to 56 degrees. For the rest of the question, you can use 55.7, but if somebody is asking you what course you want to steer, you cannot say 55.7. That's not possible. So if you have been on ships, you should know that you cannot steer a vessel in decimal course. You need a round number for that. So it's more than 0.5, so I've made it 56 degrees, right? So now we move on to the third part of the question. This is the final course. Now to get the final course, remember, it's not the internal angle B. Although I'm calling it final course, you are basically setting it up for the final course. So this is internal angle B, and then like I showed you before, to get the you need to get the outer angle to know the final course. Alright, but you will use the same principles of cosine rule, which is you've got the include B now, and you need the sides next to angle B, which is of course PB and AB, and you know that already. So putting those values here, and you know PA as well. So it's a pretty straightforward question now. All you need is the cosine rule. Again, I repeat myself that if you don't know what the cosine rule is and how it is applied, please watch my videos titled cosine rule, and you will get the clear concept about it. I also have videos about Napier's rule, and you will understand how to apply Napier's rule as well. Alright, so simply put in the values, follow my prompts, retain the negative signs if there are any, and keep going till you get cos B equals minus 0.49620. Notice how I am solving the numerator before the denominator. Alright, so do not solve it together. So solve the upper part of the equation before you solve the bottom part, and then divide the upper part by the bottom part. Once you come here at this stage here where you get cos B equals minus 0.49620, take cos to the other side, you get a cos inverse. Cos inverse of the value will give you B equals 119.7 degrees, which I have rounded it off to 120 degrees for purposes of calculating the course. Now I have told you before, this B is the internal angle B. So what you have found out is 120 is this angle here. This is 120, but you don't want the internal angle, you want the outer angle. To find the outer angle, you need to take it off 180, and that will give you the course. So in this case here, 180 minus 120 equals 60 degrees, and again it's less than 90. You are still going in an easterly direction, so it's not 60 degrees east. So your true course is 060 degrees true. Now what you have noticed here is that to determine where the vertex lies, you have to see which quadrants are your initial and final course in. And the rule of thumb is, if the initial and final course are in the same quadrants, which in this case is northeast, both the initial and final courses are in the northeast, vertex will lie outside A and B and towards the higher latitude. Alright, if the courses were in different quadrants, such as if one was northeast, the other one was southeast, the vertex would lie between A and B, still towards the higher latitude. But in this case, both the initial and final course are in the same quadrant, which is the northeast quadrant, and vertex is lying outside A and B, and again towards the higher latitude. Alright, so I have drawn the vertex in an imaginary position. There is no math involved in it. You still don't know where the position is, so it's just an approximation. Draw it outside. The vertex is always at a 90-degree angle. So you've got triangle PAV. You can also use triangle PBV and Napier's rule to solve this, but I'll be using triangle PAV. Why you can use PBV is you know outer angle B and you know PB. If you know two things, you can find out the rest of the things. I'm using PAV again because I know PA, right? And what else do I know? If I know PA and I need something else as well, so why is this taking me time? So of course I know A, right? Yeah, this is my initial course. Alright, so I have taken triangle PAV. For those of you who are taking triangle PBV, you can do so. Your answer will slightly differ from mine, but that's fine. This is fine. But you can. But I'm using PAV, right? And again, I'm using Napier's rules because Napier's rules are used when it's a right angle spherical triangle. So vertex is at a right angle, and you can use Napier's rules for that. What is Napier's rules and how do you do that? I'm not going to talk about it here. I have made a separate video on Napier's rules. Please watch that one and you will understand what Napier's rules and how do you make this circle. Otherwise this video will become too lengthy. Alright, so we've got triangle PAV. We've got the vertex outside and then sides next to the vertex is AV and PV. Then the angle opposite AV is 90 minus P, angle opposite PV is 90 minus A, and the remaining side is 90 minus PA. Alright, what do we know? We know A and I know PA, right? And what do I need to find out? I need to find out PV because this will give me the latitude of the vertex, and I need to find out P because this will give me the longitude of vertex. So angle P is always the D long between two positions. So if I find out the D long, I can apply to the longitude of A and get the longitude of the vertex. That's how it works. So Napier's rules, I'm using Napier's rules here. So first thing I need to do is find out PV. So what I will use is sine of the middle part, which is PV, equals cos of the opposites, which is 90 minus A and 90 minus PA. So this is the rule I will use. So alright, this forms a mushroom. So sine of PV equals cos 90 minus A cos 90 minus PA, and then of course cos 90 minus any angle is sine of that angle. That's why sine PV becomes sine A and sine PA. So 90 minus A is also A. Cos of 90 minus A becomes sine of A, right? Or cos 90 minus PA will become sine PA. This is the rule of trigonometry. I've made videos on this as well, so please watch my videos on trigonometry. Alright, then you simply put in the values. You know the value of A, you know the value of PA. Once you put in those values, do a transverse, do a sine inverse, and you will get PV equals 43 degrees 19.2. But the latitude of P, so PV is the distance from pole to vertex. Alright, PV, as you can see in the triangle, is from pole to vertex. This is not the latitude, this is from pole to vertex. To find the latitude, of course, what you need to do is from 0 degrees you need to find out. So to do that, once you find out PV, just subtract it from 90 and you get your latitude. You are in the northern hemisphere because you are closer to B, you are towards the high latitude, so that's where your latitude is 46 degrees 40.8 minutes north. To find angle P, use the other sine rule. So again, sine of middle, which is 90 minus PA, equals tan of adjacent. So if I erase this, and you know this is what happens with such long questions and with so much writing going on, it all becomes very cluttered and there's so much writing going on. Students tend to get confused, they lose track, and that's why I'm making these videos so that you can watch them part by part. It gets a bit lengthy, but you need to have some patience and watch it part by part and solve it, and I can't make it very long either. Alright, so I need to find P, and what do I have? I know PA. Sorry, this is not what I wanted to do. I still need my circles. I'll make one just for now. I just erased it. So I had my A and I had my PA. So normally Napier's rules, you only use the ones which were given to you before, which you knew. Although I found out PV, I'm not using it. So using A and PA, I'm finding out P. So I'll use my other rule which says that 90 minus PA is the middle part, and P, 90 minus P and 90 minus A become the adjacents. So I will use 90 minus PA, and this is what I was doing here, becomes equals tan of 90 minus A and tan 90 minus P. Alright, and then of course sine 90 minus A becomes cos PA. This is the rule of trigonometry, and then I simply transpose the values. I find out what I don't know. Eventually coming down here, just put the values in the calculator, follow what I have done step by step. You can see that I've got tan 90 minus P equals minus 0.81656. Retain the negative signs, do not ignore the negative signs, and then of course you do a tan inverse. You find out P equals 129 degrees 14 minutes. Coming back here, you know that P in this case, in the big triangle PAV, angle P becomes the D long. So remember, in the first step we calculated D long between A and B and we found out angle P. So in this big triangle PAV, P will give you the D long between A and B. So A's longitude you know, which is given to you in the question. What you need to find out here, so we are here somewhere, do not lose track, we are here somewhere, and longitude of A is given to you as 151 degrees 16 minutes east. Longitude D long is 129 degrees 14 minutes east, So you are very close to the anti-meridian. You have moved over to the other side, which is the east longitude, and what you have done is uh, uh, found out the longitude of the vortex as 79 degrees 30 minutes. Alright, so conceptually you actually added the two, or you can say, and then subtracted from 360, or you can also say that you added 180 and then did that, so whatever works for you. Alright, so you found out the d long. So because if you are trying to find out the d long between A and V, right? So A and E are in the opposite hemispheres, not hemispheres, but east and west sides. So normally you would add the two and it would become more than 180. You will have to subtract it from 360. So that's what you did. So if longitude of A plus longitude of the vortex give you d long, so naturally to find out longitude of V, you will subtract d long from A. Right? So that's how it's working. So don't get confused by all that. You can find it out conceptually as well. Alright, so it's conceptually, if you want to find out, you are here, longitude of the vortex is A is here. Now I'm kind of started to blabber now, I realize. So this is 180 degrees. Alright, so let me come clear to the point. This is A longitude is 151 degrees 16 minutes east. You have to go 129 degrees 14 minutes to find out longitude of the vortex. This is what I'm doing. Alright, so and this is 180, so you have to move on to the other side. This is how I found out. Alright, let's come to the fourth part of the question now. I'm trying to find out the intermediate points, which is longitude is given to me as 175 degrees east, and I've named it point M, and latitude is given to me as 30 degrees north, which is I've named N, and I have to find out the latitude of M and the longitude of N. And basically what you have to do is solve the two triangles using the vertex as a common point. So you solve triangle PVN first, where you have the latitude of N. If you have the latitude of N, you can see that I have found out PN 90 minus 30 will give me 60 degrees. So latitude is given to me as 30 degrees, and PN will become 90 minus 30 equals 60 degrees. Alright, so you got PN and you also know PV. You have found out that out before. If you know two things, then you've got Napier's rules, and you can see here that's what I've done. You know PV and you know PN. You basically have to find out the longitude. To find out the longitude of N, you basically have to find out this here, d long between N and V, similar to what I've done before. And once you do that, this is a tan adjacent rule. Okay, so P becomes middle part, and PV and 90 minus PN becomes your adjacent. So that's giving you our mushroom as well. Alright, you do that, put in the rules here, and you find out P. Once you find out P, you know the longitude of the vortex. Now this is a different triangle. This is triangle, see, PVN. So again, do not get confused by P. This is a different P now. Alright, so in triangle PVN, you have found out P, and you know the longitude of the vortex. You calculated it before. All you have to do is now apply it. From vortex, you are going from west, you are going further west. That's why you will add to it, right? So that's what I've done. I've got longitude of 30 minutes west. You are going back towards the anti-meridian of 180. You are going in a westerly fashion, so you are adding to the 57 degrees, and that's why your longitude is 136.30.8. Alright, the next triangle we'll do is PVM, where you had your longitude given to you as 175 degrees. It's very close to the anti-meridian, so you know that in this case you know the d long between the longitude of M and longitude of V, because you have both the longitudes, right? So in this case, the d long between V and M, again there are two, one is in west, one is in east. You will add them and then subtract it from 360 degrees. You will get the longitude. Alright, and of course you are going towards west, so that's why your d long is west, right? Then what you have to do is, you got PV in the triangle because you've done that before. You've got angle P as well. You have this d long, and you have to find out PM, because that gives you the vortex, the latitude of the intermediate point. Because you find out PM, you can subtract it from 90, or you can add 90 depending on where you are. So here the P becomes the middle part, and tan of adjacence becomes PV, and tan 90 minus PM. Using the Napier's rule, just follow my prompts, sin 90 minus P. This is the equation. Find out the one that you don't know. use the unknown, use the known to find out the unknown, and once you get PM, you know that you are on to the other side. So why I said other side is because this is value is more than 90 degrees, right? So that means your M is now in the southern hemisphere, so your equator is probably somewhere here. And again, it's not to scale, so please excuse me. So you are now here. So because it's more than 90, that means PM, this is from P to the equator is 90 degrees, right? So PM is more than 90 means you are somewhere here. So if it's 105.8, which is the case here, just subtract it from 90. So your latitude becomes 15 degrees 49.3 minutes south. So 0.8 is 49.3, 15.8 degrees, right? So that's how you do the question. I know this video is a bit long and it becomes a bit lengthy, and I've skipped in parts, but you get the idea why. So keep pausing it and watch it and again. I'm not wasting too much time on Napier's rules. You should watch the other video on that, and I've tried to concentrate more on the principles and the procedures here, and that's what you should be focusing on as well. Alright, not on the math, so you can do the math, you can follow my values. If you have any questions, please feel free to write or shoot me comments on my YouTube video, and I'll see you guys very soon with another video. I'll try to keep these videos short. These are really long questions. One of the lengthiest problems in nautical navigation is of a great circle sailing with intermediate points. Alright, so if you have any questions, please feel to write to me and watch this video multiple times to get a good understanding of the concepts of the great circle sailing. Alright guys.